Hello everyone, I'm Onur Ayan and I'm a PhD student at the Chair of Communication Networks since January 2017. My research focuses on network control systems, but before I explain you what network control systems are, I will give you the most common example, which is a remote controlled car. In the example of a remote controlled car, how the car should move around is determined by the actions of a human who is holding the remote controller, and this information is sent over the wireless channel towards the car. This toy that most of us are familiar with from our childhood is just a simple example of a network control system. Now let us have a look at the formal definition and some other examples. Networked control systems are feedback control loops closed over a communication network. They consist of a plant, a controller, one or more sensors measuring the plant state, and a communication network to exchange information between those components. If you look at some other examples of network control systems, an unmanned aerial vehicle, a robot arm, temperature control, or autonomous driving, you will notice that regular and timely exchange of information between the components of the feedback control loop plays a key role for good performance. In the example of a remote controlled car, the car itself is the plant object that we want to control, and the trajectory of the car is determined by the human, which is the controller in this scenario. But in another typical example, like autonomous driving, some sensors need to be installed on the car. For example, it can be cameras or some distance measuring sensors to measure the road state, and this information should be provided to the computer, which is deciding on the trajectory of the car. At this point, we ask the following question. Given such a scenario, autonomous driving for instance, how do we measure information? One of the first metrics that one can think of is the age of information. It is defined as the elapsed time since the generation of the latest received information. It measures the information freshness at the receiver, monitoring and controlling a remote process. Suppose that this frame was recorded by a camera on top of a vehicle and transmitted to the controller. If this is the latest information available, the controller will have this vision about the road state. However, if this information is outdated, it may affect the trajectory or actions decided by the controller. In particular, if one of the pedestrians is trying to cross the road, the controller may decide to slow down the vehicle to avoid any physical damage. If you recall, age of information is defined as the elapsed time, so therefore it increases linearly in time. However, it does not state anything about the information content or about the type of the application, and in a typical network control system scenario, we may have to deal with different types of applications within the same network, so therefore we have to go beyond the metric of age of information. If we consider two example scenarios, first one being autonomous driving and the second one being temperature control, if I tell you the latest information available at the controller is a frame that is 5 seconds old, you could argue that it's a rapidly changing environment and expect to have some major changes in the road state within the last 5 seconds. However, in the second example, if I tell you the same thing, your latest measurement is a 5 seconds old measurement, you could argue that it's a slower dynamic than in the first one, so therefore you could expect to have less changes compared to the autonomous driving example. From the communication network's perspective, it is beneficial to take the type of the application into account together with the information content and freshness. By modeling the dynamics of the applications and deriving control-aware metrics, the communication network can provide better service to the users. A possible use case is the distribution of limited network resources among different control applications. In my previous research, I have given a few possible ways of doing so and compared it to the existing resource allocation methods in the literature. If you are interested in my previous work or you are looking for a possible collaboration, please feel free to contact me, and thanks for watching.